Hello there, welcome to this lesson on multiples, common multiples, and lowest common multiples. So we start with multiples. 4 divides 4, 8, 12, 16, 20, 24, 28, etc. We then say 4, 8, 12, 16, 20, 24, 28, etc. are multiples of 4. So we can now look at other numbers. Multiples of A3 are 3, 6, 9, 12, 15, 18, 21, etc. The list is endless. Also, we have multiples of 7 to be 7, 14, 21, 28, 35, 42, etc. And finally, we have multiples of 10 to be 10, 20, 30, 40, 50, etc. So these are multiples of numbers as explained in this slide. We then go to common multiples. For common multiples, we'll be looking at taking two different numbers, find their multiples, and look at the ones that are common to them. So we look at this, list the multiples of 8 and 12, which ones are common. So we start with the multiples of 8, which are 8, 16, 24, 32, 40, 48, etc. And then the multiples of 12 are 12, 24, 36, 48, 60, 72, etc. So we now look at their common multiples now, which are, we have 12 here, there's no 12 here, 16, no, 24, we have 24 here, 48, etc. So in this type of problem, if you are requested to give about 3 or 4, it is acceptable after getting the first one, you then multiply by 2 to get the next one. If you look at this now, 24 times 2 gives 48. Multiply by 3 to get the next one, which will give you 72, and so on. So we now look at the lowest common multiple from here now is 24. So we now find a proper way of finding the lowest common multiples of numbers. So that will take us to the next slide, lowest common multiple, popularly known as LCM. So we take our first problem. Find the LCM of 16 and 24. So what we do is we create a table. The There are two numbers. The first number goes into the second column and the second number goes to the last column. In this case, unlike the HCF where we look for the numbers that can divide both numbers at the same time, but here we are only looking for the number that can divide any of them starting from 2, 3, 5, 6. Still remember we are going to be looking for the prime numbers. So the first number that can divide even both of them is 2. 16 divided by 2 gives 8. 24 divided by 2 gives 12. We go with 2 again. 8 divided by 2 gives 4. 12 divided by 2 gives 6. 2 can still divide. 4 divided by 2 gives 2. 6 divided by 2 gives 3. 2 divides again. 2 divided by 2 gives 1. And 3 cannot be divisible by 2, so we retain the 3. So 3 can divide 3. So we now have our 1 here, and 3 divided by 3 gives 1. So to get the LCM now, we multiply out all these divisors. So we now have it as 2 times 2 times 2 times 2 times 3. 3 times 2 gives 6 times 2, 12, 24. That will give us 48 as the LCM of 16 and 24. So we go to problem 2. For problem 2, we are to find the LCM of 6, 8, and 12 in a tabular form again. I have 6 here, 8, and 12. 2 can divide all of them, so we have 2. 6 divided by 2 gives 3. 8 divided by 2 gives 4. 12 divided by 2 gives 6. Since 2 can divide any of them again, we go with 2. 2 cannot divide 3, we retain the 3. 4 divided by 2 gives 4. 6 divided by 2 gives 3. Again, 2 can divide one of them, so we go with 2. 3 cannot be divisible by 2, so 2 divided by 2 is 1, and 3 cannot be divisible by 2, we retain the 3. This is the method. So we now go with 3. 3 divides the remaining 3. So we have 3 divide 3 here, 1. So we are bringing down this 1. And 3 divides 3 gives 1. So the LCM now again, we're going to have it as 2 times 2 times 2 times 3. This 2 times 2 times 2 times 3. This is giving us 6, 12, 24. And the LCM is 24. That's all for problem 2. We go to problem 3. We have to find the LCM of 6, 10, and 15. Still in a tabular form, 6 goes into the second column, 10 and 15 in that order. Again, 2 can divide 6 and 10, so we go with 2. 6 divided by 2 gives 3. 10 divided by 2 gives 5. 15 is not divisible by 2, so we retain the 15. So from here again, 3 can divide both 3 and 15. So we go with 3. 3 divides 3 gives 1. 5 cannot be divisible by 3. We retain that 5. And 15 divided by 3 gives 5. So we now go with 5 as our divisor. So 5, this is going to give us 1, 1, 1. All in all, you continue until you have 1, 1, 1 or 1 and 1 before you stop. So that our LCM now will be 2 times 3 times 5. 5 times 3 is 15. 15 times 2 gives 30. The LCM of 6, 10, and 15 is 30. Then we go to problem 4. For problem 4, this is product of prime numbers. Each number here is being expressed as product of prime number. The first number here is 2 times 2 times 3. The next number is 2 times 3 times 3. And the third number is 2 times 2 times 3 times 3. We now leave our answer as product of prime numbers. So we start with the first number here, which is 2 times 2 times 3. The next number is 2 times 3 times 3. And the last number is 2 times 2 times 3 times 3. So to get the LCM here, we are looking for the highest appearance of each of the numbers. Like in the first number here, that's the first line, we have 2 appearing twice, but it is appearing once here, it is appearing twice here. So we go for the twice appearance, so which is either the first one or this. We're not going for only one appearance, we are going for the 2 appearances. So we are going to have 2 times 2. Okay, then the next thing is we go for 3. 3 appears twice here, and it appears once twice here. So we are going for the 2 appearances again. We just pick one so that we now have it times 3 times 3, which gives the LCM of the number represented in problem 4 as product of prime numbers. So that's all for example 4. We go to example 5. For example 5, this is express product of prime numbers in index form. So the first set of numbers, we have 2 raised to power 2 times 3 squared times 5, 2 raised to power 3 times 3 squared times 5, 2 raised to power 3 times 5 squared. So we bring out the numbers in that order. Again, to find the LCM, we are looking for the highest power or the highest index of each of the numbers represented. We have 2 raised to power 2 here, 2 raised to power 3, 2 raised to power 3. So we are going for 2 raised to power 3. So we pick the 2 raised to power 3. And again, we have 3 squared, and 3. We are going for the highest power, which is 3 squared. And in the same way, this is 5, 5, this is 5 squared. We go for the 5 squared, which is times 5. Therefore, 2 raised to the power 3 times 3 squared times 5 squared gives the LCM of the number represented in problem 5. Is that okay? So we go to the next phase, which is mixed problems on LCM and HCF. So we have our problem. Divide the LCM of 8, 12, and 24 by their HCF. So we start with the LCM, creating our table. 8 comes here, 12 and 24. Any number, so 2 goes. Here we are going to have 4, 6, and 12. Remember, 24 divided by 2, 12 divided by 2, and 8 divided by 2. 2 goes again. So this is giving us 2, 3, and 6. 2 still goes. So this is going to give us 1. 2 cannot divide this. I bring the 3. 6 divided by 2 gives 3. 3 goes finally. We have 1, 1, 1. So our LCM here is going to be 2 times 2 times 2 times 3. This is 6, 12, 24. So the LCM is 24. We go for their HCF. So still in a tabular form, 8, 12, and 24. This time around, we are interested in a number that is a prime number that can divide all of them at the same time. So 2 divides all of them. So we are going to have it as 4, 6, and 12. 2 can divide again 4, 6, and 12. So we go with 2. This is 2, 3, and 6. 2 cannot divide 3, and 3 cannot divide 2. So we are stopping here, so that the HCF will be 2 times 2. And 2 times 2 gives 4, which is the HCF of 8, 12, and 24. And now we are to divide LCM by the HCF. So LCM divided by HCF is going to give us 24 divided by 4, and that gives 6. So we go for the second number under mixed problems on LCM and HCF. So this is 2A and B. We start with A. Starting with A, the first number is 2 times 2 times 3 times 3. I have it here. 2 times 3 times 3, I have it. And 2 times 2 times 3, I have it. For LCM, we are interested in the highest appearance. This is appearing twice. This is appearing twice. So we have 2 times 2, and 3 is appearing twice. 3 is appearing twice, and once here. So we're going for the highest appearance, which is 3 times 3. That gives the LCM. Then for the HCF, we go for least appearance. So twice here, once, twice. So we go for once. And here again, twice here, once. We go for once. So the HCF is 2 times 3. We are expected to give our answer in the form they are given. So that's all for 2A. We look at 2B. Again, the first number is 2 squared times 3 squared times 7. I have it here. 3 cubed times 3 squared times 7. I have it here. And the last number is 2 cubed times 3 times 7 squared. For LCM, we have the highest index. We go for the highest index. The highest index of 2 here is 2 raised to the power 3. It's forming part of our LCM. And the highest index of 3 here is 3 squared. So we have 3 squared. And the highest index of 7 is 7 squared. We go for the HCF. For the HCF, we go for the lowest index. For 2, 2 squared. And for 3, we have the lowest index, which is 3 raised to the power 1, as the same thing as 3. So we have it as 3, and lowest index there is 7 raised to the power 1. So we have it as 7. And that's all for mixed problem 2 under mixed problems on LCM and HCF. And this is the end of the lesson. I hope you enjoyed it. Thank you for watching. Goodbye.